I'm Jordan.
I'm Hisham.
I'm Austin.
I'm Sydney.
And I'm Alex.
Alright, so we did a transition from dinosaurs to birds, and you might think that they evolved from dinosaurs such as pterodactyls, but actually they evolved from dinosaurs that were ground dwelling, such as tetrapods.
Okay, the first trait we have right here.
That's a dinosaur. Yeah, that's
This
a dinosaur
right here.
head.
This right here is the dinosaur head. This right here is the head of the bird. Okay, as it appears right now, they don't seem too similar. It doesn't really look like this head evolved from that, but contrary to belief, the way that the bird of the head of the bird evolved actually goes back to dinosaur eggs. A scientist named Absinoff, or a paleontologist, I'm sorry, named Absinoff studied dinosaur eggs, and he found out that the fossils of dinosaur eggs were very similar to the head of modern day adult birds. So the embryo of a dinosaur was almost identical to the adult bird head, which signified that the bird developed less and less from the embryonic stage, and that is called paleomorphosis, which is when a pre-existing feature just is extended. Now to talk about the beak, these two bones right here form the beak, which is called the premaxillary bones, and it's also present in the dinosaur head, except that these two bones evolved and they fused out, and instead in the dinosaur they kind of they didn't fuse, they stayed apart and they formed the snout.
So a lot of the things when we look at dinosaurs and modern day birds is like, well, dinosaurs were huge, and a lot of birds are really tiny. And what actually happened was the dinosaurs started shrinking over time. This was like around 250, 300 million years ago. And eventually they got to the point where, they were about like 3 feet tall, and they just ran around. And they really you wouldn't think that they're harmless. So how many of you guys have watched Jurassic Park? You remember in the second movie where that little girl gets attacked by the little dinosaurs? Or the third movie? That's kind of like what the dinosaurs eventually turned into, and then they turned into little birds. So the next thing we're actually going to talk about is this whole torso and the chest and the pelvic girdle. I don't see how I built it. Building this was not fun. Yeah, like that. Okay, wait. There we go. Okay. So in dinosaurs, the pelvic girdle is virtually almost non-existent. They didn't really use it as much, and a lot of the bones in the dinosaurs were really thick and they were heavy because those were big creatures. Then birds, if you look at bones, are actually very thin and they're hollow. And what some people believe is that it actually helps them in flight in aerodynamic sense because they're so light compared to the dinosaurs. So if we build a dinosaur, I wish we could actually build a real dinosaur. That's our dinosaur torso, and it's really thick and heavy, and over time they evolved and they became smaller and lighter into this form, into this main transitional form which we called Archaeopteryx. And this was discovered around the 1860s in Germany by these mine workers. And the word Archaeopteryx actually comes from the root, which is feathered flight or first flight. So a lot of people consider this to be the first modern bird. But then scientists obviously found other fossils and other transitional animals between that time period, so it kind of the title went away. But I mean, it's the first bird. So the next thing is these are the feet, the legs. Pretty sure that was that. And then we'll put the other one. This is a lot more fun when I thought of it in my head. So then we'll build our, it's actually a turkey we're building. So that actually goes like that. And one of the other things was in the dinosaurs, they really had really big legs, and their arms were really short. So if you like think about it like a T-Rex, like the funny memes where it's like arms are like this and it's walking around, it can't really do anything. So over time, the arms actually became longer. They started to support the wings, and the birds, the legs became shorter because they didn't really use that as much for like in terms of like transportation, you know, like walking around and stuff. But some birds have longer legs, but like turkeys, they don't really fly. But that's just because that's how they walk around. So the dinosaurs had really big legs, and turkeys had really, and modern birds have like smaller legs and bigger arms. So that's what these are. The arms. That's supposed to go up though. So there are a lot of similarities and differences between the structures of dinosaurs and birds. And like people, if you think about dinosaurs and birds, most people would think that like birds came from pterodactyls, but they actually came from a different type of dinosaur called a theropod. And those are like the velociraptors and the T-Rexes, so those are like the really ground-based animals. Yeah.
So there's been some controversy over like how birds began to fly. Like one hypothesis is that the top to bottom is where like ancestral or birds would climb to the top of trees and then like jump out and like glide for like short distances, but not very far. And then over time, it's believed that they would get farther and farther as their body plans changed to allow them to go farther in flight. But then the other hypothesis is the bottom to top, which is where as dinosaurs like would run and their arms got longer, that they would jump and like glide a little off the ground, and which allowed them to catch prey easier. And this is the hypothesis that is accepted now because they found Archaeopteryx, because its body plan is the complete opposite of any of the animals that jump out of trees and glide now.
Okay, so dinosaurs actually had feathers before birds did, and there are a few things that scientists believe that led to this. First of which being that feathers obviously served insulation purposes, and it wasn't just beneficial for the actual dinosaurs, also beneficial for their offspring because it helped keep them warm before and after birth. And since dinosaurs had really good maternal care, like this was super important for them. And then also feathers, having longer feathers actually helped provide dinosaurs with balance. So as you previously heard, that they would just like run and jump after their prey. So having feathers actually like helped them glide a little bit, and it helped them not like fall all over the place. And then another thing is that the color of the feathers was actually super important. So during like the winter months, they would be a more dull color, which provided them with like a camouflage so that they weren't easily seen by predators. And then during the warmer months, the feathers would become brighter in colors, and this would help them with sexual selection. So the brighter the colors, the more attractive they were. So birds and reptiles have this thing called tetrachromatic vision, which not only allowed them to see blues, reds, and greens, it also allowed them to see ultraviolet light. So color is super important for communication between birds, so the feather color was really beneficial for this, and scales were more of a dull color, so having feathers was obviously the better choice for evolution.
Okay, and then terror birds was kind of like one of the last transitional creatures between dinosaurs and birds before the actual birds started to emerge. They appeared around 65 to 1.8 million years ago. They were large flightless birds, as you see here. They have really long legs and really short wings, and people compare them to ostriches because of the height similarities and like the longer neck and everything. And they reach speeds of around 45 kilometers per hour, and it was believed that their wings were used for either attracting mates or helping to kind of change directions when they were up at those high speeds. And as you see here is a skull of a terror bird, and you see it's got a very sharp pointed beak, and it was believed that they were omnivorous. They had it was a hollow nose bone, and they really couldn't take their prey and shake it and kind of kill it that way. They had to slam down with the pointed beak, either on their spine or on their neck, to kill them. And they also used it to rip the meat off the bones, or they would eat like plants and stuff with the back, like the back part of their mouth back here, because they couldn't, like if they tried to shake animals and stuff, they would break. And then the way they hunted, it was believed they would, since they were so large, any of their prey would see them from farther distances away and would be able to escape. So they would hunt by ambush tactics. They would hide behind trees and woods or in large piles of brush and wait for their prey to get close enough and ambush them and then chase them down and then slam their beak into them and kill them.
So if you who you just watched like the Jimmy Neutron movie, like they have to like go save their parents? Nobody? One person. Okay. So basically at the end, like the aliens kidnap their parents because they're gonna feed it to like this really big chicken. And like if you think about a terror bird, it's like a really big chicken that's gonna eat you. And imagine that like hiding, just following you, just watching you, waiting to slam its beak into you. So we actually have to finish building our dinosaur and our bird. So one of the main, like we talked about earlier, the Archaeopteryx, and one of the main reasons why we can tell that it was more a transitional animal or creature was because it had a lot of features like dinosaurs. So it had a really long, bony tail, and a lot of the bones were really separate and its joints weren't fused together. So that's what scientists like also believe, that how there was like a transitional form was like if you look at a lot of birds now, a lot of the bones are fused together. So like in a bird, most of the bones around the shoulder area actually fuse together. So when they're flying, it actually provides some sort of stability when they're in flight. And the breastbones in birds actually became thicker to also support the wings, and it also like provided stability for the muscles. So next we have to attach the necks, because they really need their necks. And our turkey neck. And then we have our tail. And like, obviously now in birds we have really short, stubby tails. So Archaeopteryx was a really important find in science when we try to look at where birds came from. And if you like look at like, you know, when you're looking for transitional fossils, you kind of also have to look at like what do they have, what don't they have. Because a lot of the times when you look at what they have, what they don't have, it kind of helps you figure out like where their similarities and differences lie in terms of animals that are extinct in the past and animals which we have now. So like, you know, people talk about how if we didn't really have Archaeopteryx, it'd be a lot harder to figure out where dinosaurs like evolved into and where birds came from. So like when you're basically, this is the way I'm going to put it, like the next time you're eating your Chick-fil-A sandwich, just like think about like you're eating a dinosaur. What that was eventually like 300 million years ago was a dinosaur, and now it's your Chick-fil-A sandwich.
Just going off of, now that we have the dinosaur and the bird completely built, I want to talk about something that Hisham had mentioned earlier. Now during this time period, you know, it's easy to assume that, you know, the biggest dinosaurs, the strongest, are most likely to survive and prosper. But however, these smaller dinosaurs were slowly prospering and had better fitness. Now the reason for this is their size. Now the size enabled them to find new food, new shelter, escape from predators, and most importantly, from evolving from dinosaurs, it enabled them to fly. If you look right here, this is the Coelosaurus, and the Coelosaurus began shrinking in size around 175 million years ago. Now the Archaeopteryx, the first evidence of any type of bird back in the dinosaur age appeared around 150 million years ago. And this began shrinking 25 million years before the Archaeopteryx had appeared, which indicates that being small was actually an advantage. You know, and then if you look right here, you can see that as soon as the small stature had formed, an intense selection began. They just got really small really fast. And that's because, again, you know, they started prospering more, and the ability to shrink and be small increased the fitness of the bird.
Any questions? Yes.
What environmental factors might have caused dinosaurs from going to this big bads to little tweeny things?
So over time, the environment kind of changed where it was like, you know, the bigger you were, like there were a lot of hazards in terms of like geographic hazards and, you know, the not being able to get food because a lot of the other animals, like, you know, like Alex talked about terror birds, since they were so huge, like their prey could see them, and they basically had an advantage in hiding. So eventually dinosaurs kind of, because of like almost really because of food and other issues, they like started to become smaller and smaller, because since they were becoming smaller, it was also harder for their prey to see them, and it was easier for them to sort of go after their prey. So that's one of the reasons why they became small.
I have questions. I don't know if you know the answer. In your research, any indication that dinos had the ability to see ultraviolet light as well? And therefore, what might be their colors?
It was present in dinosaurs, and it's actually still present in all reptiles and birds today, which shows that like they did evolve.
Oh, so dinos could see.
Yeah,
The
they
idea
could.
is they could see ultraviolet.
Yeah.
What evidence do we have for that?
Not 100% sure.
Yeah.
It was a big long article, and
Okay.
I thought it was pretty cool.
So dinosaurs were probably colorful then.
Most likely, yeah. But the scales were a lot more dull in color than the actual like feathers were. So,
But still had some color to them.
yes.
Cool. The other question I had is, the neck obviously changes, right? From a straight neck to an S shape. Why might that be? Like birds have an S-shaped neck. Dinos, a little bit of an S, but nothing like a bird.
So all birds really have the same neck, but in dinosaurs, since they had the really long tails, they were also really heavy.
Mhm.
And actually the position that you see like the dinosaur in right now, that's kind of like where it was like its normal resting position. So the neck was shorter so that the head was more close to the body. So it kind of like provide like this balance,
Mhm.
like balancing the tail. But with birds, since like the tail was really small, it kind of like allowed their necks to grow longer, since they didn't really need to stay that close to the body.
Okay. What would a long neck give you that a short neck could?
Well, you could obviously move your head around more with a longer neck, and you could go after a prey a little further and
Like
dive
this,
in.
right? You can
Yeah,
do that.
but with dinosaurs, you're kind of stuck.
You have to move your whole body if you're a dinosaur, whereas
Yeah.
a bird, you can move just your neck to grab. Other questions?
Since you said that like modern day birds evolved from ground dwelling dinosaurs, was there evidence of what the pterodactyls and flight, like the flying dinosaurs, whatever happened to them?
I mean, we weren't really focused on that.
Pterodactyls died out 100 million years.
Because like, once I read, like, we got to the point where like pterodactyls did turn into birds, we were like, well, that's not gonna help us.
Yeah.
I have a question. So you said that they progressively developed feathers. Was that like due to a change in the environment that it became more necessary, or like?
It was just more beneficial to the dinosaurs overall. Like I said, it helped with their balance. It helped with the sexual selection, and it also helped with like insulation with like the maternal care. It helped keep their offspring warm when they were first born.